Imagine a machine whose wheel alone is as tall as a house. A steel monster capable of lifting an entire fleet of warships or trucks that can swallow 500 tons of rock and earth in a single load. They are not just machines, they are engineering wonders that reshape the face of our planet. From the roaring depths of the ocean to the launch platforms that send humans into space, today Mandarin Tech will take you inside the incredible power of the top 7 most impressive heavy machines on Earth. Can you believe that humans actually built these giants? Developed by the Shanghai Zhen Hua Heavy Industries, Zhen Hua 30 is one of the most impressive offshore construction machines ever built by humans. It is a massive vessel equipped with a super heavy crane capable of lifting structures as heavy as an entire building. Zhen Hua 30 is a giant offshore crane ship. Unlike traditional cranes that operate on land, its entire lifting system is mounted on a vessel nearly 300 meters long, allowing it to travel directly to offshore construction sites where no fixed foundations exist. On the ship's deck stands a gigantic crane with a lifting capacity of about 12,000 tons, powerful enough to raise oil rig modules, enormous steel structures, or bridge sections hundreds of meters long in a single lift. The role of Zhen Hua 30 is especially important in the era of deep-sea construction. As coastal cities expand, offshore wind energy grows, and the oil and gas industry moves farther from land. Increasingly large structures must be assembled directly at sea. Instead of building them piece by piece offshore, Zhen Hua 30 allows engineers to fully assemble modules on land, transport them out to sea, and install them within just a few hours. This significantly reduces weather risks, labor costs, and construction time. What makes Zhen Hua 30 truly remarkable is not only its lifting power, but also its ability to remain stable in rough seas. Its dynamic positioning system, load balancing, and motion control technologies allow the crane to operate with centimeter-level precision, even in the constantly moving environment of the open ocean. KEMROC Cut Break is a high-precision concrete demolition tool developed for heavy structural removal, such as bridges, reinforced concrete floors, retaining walls, and large infrastructure components. The KEMROC Cut Break system works using a cut-separate controlled braking principle, allowing structures to be dismantled layer by layer with high accuracy. This device is usually mounted directly onto a hydraulic excavator, effectively turning the machine into a massive concrete cutting system. The most distinctive feature of the system is its circular cutting wheel, equipped with ultra-hard alloy teeth. During operation, the wheel rotates with high torque, carving deep grooves into reinforced concrete. Instead of smashing the entire structure at once, the machine gradually cuts a series of grooves, weakening the internal structure before the concrete sections are separated. One major advantage of this technology is its ability to handle extremely thick reinforced concrete. Bridge slabs tens of centimeters thick, even approaching a meter, can be cut layer by layer without causing strong vibrations to surrounding structures. In addition, the cut and break system significantly reduces dust and flying debris. Because the cutting process is controlled, the concrete does not explode apart like it often does when hydraulic breakers are used. Instead, larger pieces typically fall away in blocks, making waste collection and material transport easier. In practice, KEMROC Cut and Break is commonly used in complex demolition scenarios, such as dismantling old bridges, cutting reinforced concrete floors inside industrial facilities, removing retaining walls, or modifying existing infrastructure. Thanks to its combination of strong mechanical power, high precision, and low vibration, the KEMROC Cut and Break system has become one of the modern concrete demolition technologies widely used by construction and demolition contractors around the world. Rotary Snowplow is one of the most powerful snow-clearing machines ever developed for the railway industry. At the front of the train is a large steel rotor equipped with multiple cutting blades that spin continuously at high speed. As the machine moves forward, the rotor breaks apart compacted snow, grinds ice into smaller pieces, and throws the material dozens of meters away from the railway line. This special design allows rotary snowplows to handle conditions where ordinary snow removal equipment becomes completely ineffective, such as avalanches, prolonged blizzards, or thick layers of ice and snow that can build up several meters deep along mountain railways. An interesting detail is that not all rotary snowplows look the same while operating. Many classic versions in North America often produce large clouds of white steam around the front of the train. This happens because older machines use steam engines or steam-based heating systems to prevent the rotor and drive mechanisms from freezing in extremely low temperatures. The escaping steam created the iconic image of a winter monster pushing through blizzards. In contrast, modern versions in Japan and Europe use diesel, electric, and sealed hydraulic systems, allowing the machines to operate more efficiently without steam. Today, the rotary snowplow is considered the last resort solution in railway snow removal operations. It is typically deployed only when snow accumulation exceeds the capacity of conventional equipment. Although it does not directly build infrastructure, the rotary snowplow still plays a crucial role in the modern ecosystem of construction and transportation machinery, ensuring that vital rail routes remain open and economic activity continues even during the harshest winter storms. In the world of mining, where every figure is measured in millions of tons and billions of dollars, there is a machine built to push the limits of what seems physically possible. BelAZ 75710. It is not just the largest dump truck in the world. It is a statement of Belarusian industrial ambition. When you stand next to it, you don't simply feel small, you almost lose your sense of scale. BelAZ 75710 is more than 20 meters long, nearly 10 meters wide, and over 8 meters tall, roughly the size of a two-story building. But its size is only the beginning. What truly makes it iconic is its 450-ton payload capacity, and during testing, the truck has reportedly carried over 500 tons. Fully loaded, its total weight can exceed 800 tons, approaching the takeoff weight of a large commercial airplane. To move such an enormous mass, the truck uses two MTU 16V 4000 diesel engines, each with 16 cylinders, producing a combined output of about 4,600 horsepower. However, the real engineering highlight is its diesel-electric hybrid system. The engines do not drive the wheels directly. Instead, they power generators that supply electricity to 4 electric wheel motors mounted in the hubs. The total power delivered to the wheels can exceed 6,500 horsepower. As a result, this gigantic vehicle can still reach speeds of around 60 to 65 kilometers per hour, an impressive figure for something of its size. The braking system is equally advanced. In addition to hydraulic disc brakes, the truck uses dynamic electric braking, converting kinetic energy into heat and dissipating it through a forced cooling system. Another interesting feature is that both the front and rear axles are steerable, giving the truck a turning radius of about 45 meters. Meanwhile, a pneumatic hydraulic suspension system with oil and nitrogen shock absorbers helps keep the vehicle stable even when carrying full loads across rough mining terrain. With a price of around $6 million, the BelAZ 75710 is not designed for every mine, but in massive operations extracting coal, iron ore, and copper, where every cent saved per ton matters. This machine is more than just a transport vehicle. It is a tool for cost optimization on a scale rarely seen in industrial engineering. With a weight of around 800 tons, Liebherr R9800 is not just an earth-moving machine. It can be considered the center of an entire modern mining ecosystem. This giant excavator is designed to work with large mining trucks ranging from 240 to more than 360 tons. Its bucket capacity can reach up to 47.5 cubic meters, allowing it to move 75 to 90 tons of material in a single pass. Under optimal conditions, only 3 to 4 buckets are needed to fully load a 220 to 320 ton haul truck. A cycle time of under 30 seconds is not just a theoretical goal, but a real performance level achieved at many major mines around the world. This means tens of thousands of cubic meters of overburden can be moved continuously, 24 hours a day, 7 days a week. The power of the R9800 comes from its dual-engine configuration. In mines with stable electrical infrastructure, the electric drive version provides outstanding energy efficiency. Its hydraulic system contains about 10,000 liters of oil, operating through 10 main pumps and 4 swing pumps, generating enormous digging and breakout forces while still maintaining fast working cycles. The Electronic Plus system integrates control software, sensors, and real-time diagnostics, helping maximize productivity while reducing fuel consumption per ton of material. A newly designed chassis distributes about half of the machine's weight onto the undercarriage, improving stability when working on uneven terrain. Meanwhile, the operator's cabin is an entirely different world. Quiet, climate-controlled, and offering panoramic visibility. The operator controls this 800-ton steel giant with remarkable precision through joysticks and digital monitoring screens. Since its launch in 2010, only a few dozen R9800 units have been produced worldwide. Yet wherever it appears, production output tends to rise dramatically. In the mining industry, the R9800 is not simply an excavator. It represents a benchmark of performance and a symbol of humanity's ambition to dig deeper into the earth. With the Sandvik DL422iE, this heavy-duty machine represents a new generation of smart and sustainable long-hole drilling rigs. Developed in Sweden by Sandvik, this model belongs to Sandvik's I-Series, which focuses on automation, data connectivity, and optimized drilling cycles for large-scale metal mines. Sandvik DL422iE is designed for long-hole drilling used in underground mining methods such as sub-level stopping. Its dual-boom structure increases the coverage area of the working face, allowing multiple holes to be drilled simultaneously with high precision. The intelligent control system integrates positioning software and real-time drilling parameter monitoring, ensuring that hole straightness, depth, and diameter meet design specifications. This directly improves blasting efficiency while reducing ore loss. One of the major differences of the DL422iE version lies in its electric drive system. Instead of relying entirely on diesel engines, the machine uses electrical power to operate the drilling system. This significantly reduces emissions and heat inside underground tunnels, a critical advantage for improving working conditions and lowering ventilation costs in deep mines. With a length of about 11.4 meters, a width of 2.4 meters, and a weight of roughly 22 tons, the DL422iE is compact enough to maneuver through underground tunnels while still delivering powerful drilling performance. Combined with automation capability, remote operation, and integrated mine data management systems, the Sandvik DL422iE can be seen as a technological platform helping underground mines move closer to smart, safe, and sustainable mining operations. Somewhere else, there is a machine that does not serve mines, construction sites, or the open ocean, but a much greater goal, carrying humanity's ambitions toward new worlds. Built in the 1960s, the Crawler Transporter is the largest self-propelled land vehicle ever created. Since 1965, 2 of these massive machines operated by NASA have transported nearly every major rocket used in American space missions. With its own weight of about 6.6 million pounds and an upgraded carrying capacity of at least 18 million pounds, the Crawler can move the entire Space Launch System and its mobile launch platform, which together weigh around 16 million pounds. The journey covers roughly 4 miles, moving at a speed of only about 1 mile per hour, and takes more than 10 hours to complete. But this slow pace is necessary when transporting one of the most complex and expensive structures ever built by humans. Inside the $144 million machine, a powerful electrical system provides energy for motors, pumps, and cooling fans. Meanwhile, the JL leveling system keeps the entire load perfectly balanced, even when the Crawler climbs slopes with elevation differences of up to 5 feet between its ends. Operating this vehicle requires a team of 25 to 35 engineers and technicians. 2 control cabins located at opposite corners allow drivers to change direction without reversing. The Great Circle steering mode allows all 4 Crawler tracks to rotate along a large arc. But with a steering limit of only 6 degrees, every turn becomes a carefully calculated maneuver. Over the past decade, NASA spent 5 years upgrading the structural components that carry the entire weight of the system, increasing its capacity from 12 million to 18 million pounds. Every component among its more than 70,000 parts must function perfectly, because even a small failure could delay a mission worth billions of dollars. The crawler transporter is not a flying machine, and it rarely appears on the front page. Yet for nearly 60 years of American space missions, this slow-moving giant has always taken the first step, carrying humanity's dream of leaving Earth closer to the launch pad. The machines you have just seen are only a small part of the vast world of heavy machinery. They build bridges, extract natural resources, keep transportation running during snowstorms, and even play a role in humanity's space missions. Heavy machinery is not just about massive blocks of steel. They are the result of decades of engineering research, mechanical innovation, and humanity's constant ambition to build structures that are bigger, deeper, and farther than ever before. And if you want to discover more giant machines operating behind the modern world, like the video, subscribe to Mandarin Tech, and turn on notifications so you don't miss the next episodes. Also, let us know in the comments which machine in this video impressed you the most.